this question, we are given that the equation of a curve is y is equals to x squared plus 5x plus b. Alright, now what we want is to find the values or the range for which the line y equals 3x plus 2 is a tangent to this curve. Okay, so the first thing is, looking at this expression, since the coefficient of x squared here is a positive number, it's a 1, though it's not written, it's a positive 1. So we know that the curve looks something like this. Correct? Now this line here, y equals to 3x plus 2, also has a positive gradient, positive 3. So we know that it's a upward sloping line. Correct? So for this line to be a tangent to the curve, when you say it's a tangent, it means that it touches the curve at exactly one point, correct? Now for this line to be a tangent to this curve, we can expect that the line to be somewhere around here, correct? So it touches the curve at one particular point here. All right. Now, where it touches the curve, at that point of time, the gradient of the curve will match the gradient of the straight line. Okay, so in that case, we know that since we know that the gradient or the tangent of the straight line is a fixed value, which is 3, the gradient of the curve at that point of time must also be 3, correct? And to find the gradient, all right, we can differentiate this expression, correct? So y is equals to x squared plus 5x plus b. All right, if I differentiate it, okay, if I differentiate it, I get dy dx is equals to 2x plus 5. All right, and we know that at this particular point, okay, at this particular point, the dy dx or the gradient is equals to 3, correct? Because it matches the gradient of the line. All right, so if I were to substitute 2x plus 5 equals to 3, I will get x is equals to minus 1. All right, if I substitute x equals to minus 1, all right, into this straight line equation, y is equals to 3x plus 2. If I substitute x equals to minus 1, I'll get that y is also equals to minus 1. Correct? Now I take these values of x equals to minus 1, y equals to minus 1, and put them inside here. Correct? Inside this expression here. So what I will get is minus 1 equals to minus 1 squared plus 5 into minus 1 plus b. All right, and if I evaluate that, I'll get b is equals to 3. All right, so that is how you approach this question. You need to look at the gradient of the curve, okay, and get the expression by doing a differentiation. And after that, we say that this is equals to 3 because that is the only point where the line will be a tangent to the curve. All right, so for part 1, the answer is when b is equals to 3. All right. For part 2, all right, what we are asked is the range of values for which y equals 3x plus 2 does not meet the curve. Okay, so if you look at the sketch over here, you can see that when the line is a tangent to the curve is where you meet it at exactly one point, correct? In order for the line to not meet the curve, okay, in order for the line to not meet the curve must actually shift higher, correct? Because if the curve shifts lower, okay, so let me draw it for you. If the curve shifts lower, all right, then the line will touch the curve at more points, correct? But if the curve shifts higher, then there will always be a gap between the curve and the line. All right, so the way for the curve to move higher is when the value of b, all right, so the b is the constant, which is actually the y-intercept, right, where it touches the y-axis. So if the value of b keeps increasing, so that is where the curve actually will continue to go up. All right, so in order for the line y equals 3x plus 2 to not meet the curve, All right, the range of values would be when b is greater than 3. All right, for it to meet it exactly at one point, that means to be a tangent, the value is when b is equals to 3. All right, so I hope this sort of gives you a good understanding on how to approach this question, all right, by using differentiation. And of course, as you can see, by having a good idea on how to sketch graphs and lines very quickly, you can also use that to have a better understanding on the question and how to approach it. All right, so thank you for watching. All right, bye.